So we're going to do two worksheets today. Look at the sine, cosine, tangent worksheets first. It is. So if I have a right triangle, and then I have to pick what is called a reference angle. And the reference angle cannot be the right angle. Let's see why in a second. So I'll pick this as my reference angle, and I call it theta. Anyone ever heard of theta before? I can show you. This one, I think. Okay. So here is the Greek alphabet, 24 characters instead of 26. Some of them look very similar to our alphabet. So alpha, beta, gamma, delta, epsilon, zeta, eta, and then that one is theta, lowercase theta. And it keeps going. Iota, kappa, lambda, mu, nu. I don't know what that one is. Anyway, but you can see lowercase pi. Pi is just a Greek letter. Uppercase pi is this funny rectangle without a bottom. So whenever in trig we talk about angles, we always use theta to denote the reference angle. What's that? Alpha? So lowercase theta is a circle with a line through it. Whenever you see theta, it means an angle, the reference angle. Well, it's not, anyway. So the reference angle can be any of the two base angles of the right triangle. It cannot be the 90-degree angle. So the longest side of a right triangle is called the hypotenuse. Anybody know what that word means in Greek? It's an occupied toilet on a mountain. Camry is the thinker. Hypotenuse. Okay. I don't think I'm going to be a stand-up comedian anytime soon. Or okay. So what do we call the leg that touches theta? What's the name of the side, the leg, that actually intersects theta? So this side is called adjacent. Adjacent just means next to. So you label the hypotenuse first. The adjacent side is the leg that touches theta. And then the other side is referred to as opposite. So what if I move theta to the other side? Then the adjacent and the opposite switch, and the hypotenuse never changes. What if I tried to put theta on the right angle? Then the hypotenuse becomes the opposite, and instead of a single adjacent, we end up having two adjacents, which ruins everything we're going to do. So theta cannot be the right angle. Okay? So once I've labeled theta, trigonometry is the study of the ratios of the sides of a right triangle. And you can actually extend it beyond right triangles, but we're not going to do that this year. So with reference to theta, if I pick any two side lengths and divide them, I end up with a ratio. So let's say that I had a 53-degree angle, and then the adjacent side was 3, and the opposite side was 4, and the hypotenuse would be 5. Okay? And I divided the opposite side by the hypotenuse, 4/5. That's just a ratio. Okay? And ratios can be written as a percentage, 0.8, which means 80%. The decimal, turn it into a percentage, 0.8. So that means If theta is 53 degrees, then the opposite side is 80% as long as the hypotenuse. Okay? Does that make sense? So when theta equals 50, 53, then the opposite side divided by the hypotenuse is 80%. Okay? What if I doubled the size of the triangle? So now it was 8, 10, 6, and it's still a 53-degree angle. It's the same because the triangles are similar, right? So what does this 80% depend on? The angle, right. So that 80% depends on the angle. It doesn't depend on the size of the triangle. And because of that, because the ratio depends on the angle, well, not really. So as long as this is a 53-degree angle, if I were to erase all those sides, and I were to just label this opposite and hypotenuse, then that ratio is always 80%, no matter what the size of the triangle is. But if I had one side, then I could use the angle to find the other side. So because the ratio is tied to the angle, we give the ratio a name. The name of this ratio is the sine. Okay? I don't know where the name came from, but we've just given that particular ratio a name. The other ratios are cosine, tangent. How many ratios are there in one right triangle? 6. Because I could do from here to here, here to here. So there are 6 ratios. Sine, cosine, and tangent are the most frequent, but we could do sine backwards, and we get what is called the cosecant. And the reciprocal of cosine is called the secant, and the reciprocal of tangent is called the cotangent. So all of these ratios tell you what the percentage is for that particular relationship. So on your worksheet, we have to define all of these. Sine is just O over H. You tell me theta, and I'll tell you what the ratio is. Okay? Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Hold on, we'll get there. And then the other 3, as long as you have them lined up correctly, you just need to know that they're reciprocals. Tangent and cotangent go together, so this is A over O. And it would make more sense if secant and sine were matched up and cosine and cosecant, but that's not the case. Sine matches with cosecant, so cosecant is H over O, and cosine matches with secant, so it's H over A. Now, last year, hopefully you learned the mnemonic SOHCAHTOA. You guys have heard of that? Well, let me show you how to program things in your calculator. So if you're not good at remembering this kind of stuff, you can just look it up. So pull out your calculators. You can program it. I don't know how. So just, well, I'll show you the basics. It should be the same. Okay, push program. Okay, push program, go over to new, hit enter, and type in trig. Yeah, I'll switch it. I need to look at one. So create a program called trig. Just push program, go over to new, hit enter, and write trig. So it should look like this. Hit trig and then hit enter. Let's look at yours. You should have a button that says program.
I do, but it doesn't fit the
Excuse me. So let's just go. Let's go to the regular equation page, the calculate page. Okay. I don't know. No idea. Okay, is everybody this far? It's in alphabetical order. Okay, now there is a programming language. Equals means something. There are lots of things, but you don't need to know the programming language. I don't know it. We're not going to really write a program. We're going to use this as a note page. So ACT, core test. There's something you want to remember that you're sure you're going to forget, just program it in. So I'm going to type in here SOHCAHTOA. So you could push alpha and then alpha letter, alpha letter, alpha letter. That's annoying. If you push second alpha, then it locks on alpha. So you don't have to push it every time. Yeah, create a new one. Call it trig. So SOHCAH TOA. And then I could also put, so if I wanted to, CSC, oh dang it, what did I do? Oh, I hit enter, which ruined the alpha lock. Okay, so I want to go to edit, edit trig. So down here, I'm going to write alpha lock CSC, and then I could push this button, which is a space, and I could write H, there's H, O. Okay, so SOHCAHTOA, that has everything I need there, and I have cosecant is H over O, and I could program the others in there. Well, whatever you want. You're doing this for yourself, so whatever makes sense for you. The space is the 0, the little underscore. Okay, now let me show you how to access this. Exit out, and go to Program, and the first exit out, second quit. Go to Program, and then I'm going to go down to trig and hit enter, and it says program trig, meaning run the program. Well, if I hit enter on that, I just wrote a bunch of gibberish that the calculator doesn't understand. We don't want to use it as a program. We just want to be able to view what we put in there. So well, you'd need to understand the programming language, but yes, you could. So push program, and then I'm going to go over to edit. I want to edit my trig program, and there are my notes. Okay, and there is no save button. Anything you type in there, when you exit, it's automatically saved. So you can write as many programs as will fit, and you call them whatever you want, and you can write whatever notes you want on there, like quadratic formula, Pythagorean theorem, any equation, volume, surface area. You can program all of those in, and the calculator won't understand what the program is for, but if you just go into edit, you can view your notes. So that's kind of something that's nice. Okay, so if I had a right triangle, and it was a 5, 12, 13 triangle, and it is a right triangle, thank you, and I asked you, what is the sine of A? Well, sine is O over A. So O over, oh, did I I say A? Sorry, over H. That's what I meant. So it's going to be 12 over 13. Now, I didn't know what the angle was, and that's okay. I don't need the angle in this case. So 12 over 13 is my answer, which is, you don't need the percentage here. Just write the ratio. Yes. For A is up here. Right. So if I did tangent of B, then I need to move my theta to B. What is the tangent of B? Right. Once I move theta to B, the opposite and the adjacent switch. So this is 5/12. Okay. What about the cosecant of A? Well, cosecant is the reciprocal of sine. The sine of A is 12/13. So the cosecant is going to be 13/12. So that worksheet's pretty simple. And I believe one of them has a wrong answer. There's an 8 or something that shouldn't be on the answer sheet. You'll notice. It's super obvious. Go to the other worksheet. Now we're on the single page. Yes. Okay. So we're going to review really quickly the Pythagorean theorem, and then we'll use trig to do some solving. So according to the Pythagorean theorem in this first problem, what letter am I missing? C. So it's going to be 25 squared plus 8 squared equals C squared. You guys all know how to find that, right? 625 plus 64, square root it. What do you get? Yeah, what's the square root of 625 plus 64? 26.32? 26.2. Okay, how am I going to find the second one? Well, I'm missing... Well, we can't do tangent because we don't have an angle. Good. 8 squared plus b squared equals 10 squared. So that's 100, and I'm going to subtract 64, which is 36. So b squared equals 36. So my answer would be 6. Why is it not plus or minus 6? Shouldn't we get a plus or minus when we square root b squared? Right. The story, the context in this case, negatives don't make sense. There's no such thing as a negative distance until next chapter, and then negative distances do exist. Yeah. Stay tuned. Okay, I'll leave the last one for you to do. So what if we're given a triangle, a right triangle, with only one side length? Can we find the other side lengths? Yes. Well, we know it's a right triangle. Okay. What could we use to find the other two sides? Well, remember how I said that the ratios are tied to angles. Remember that 80% ratio I talked about? What was the angle it was tied to? It was 53. So if this is 53 degrees, then I could tell you what this is. Well, now I'm telling you it's 53. So if we know the angle, then we can use the ratio to figure out what the missing side is. We do know it's 53. I'm now defining that angle as 53. Okay, so what part of the triangle am I trying to find? Which side? The hypotenuse. Okay, so what side of the triangle do I know? Which side do I already know? I know the 6, and the name of the 6 is opposite. So, if I know the opposite, and I'm trying to figure out the hypotenuse. Which trig function do I use? Well, there are two of them that use O and H. O and H. Sine or the cosecant. But guess what? There is no cosecant button anywhere in your calculator at all. So we're going to use the sine. Right. So the sine of 53 degrees is equal to 6 over H. Does everybody understand how I set that up? So I was looking for H just because I need to find both of them, but I picked H. I want to find H. The only side I know is O. And here's my theta. This is my theta at 53 degrees. So I know O. I'm looking for H. So in SOHCAHTOA, what is the only one that includes O and H? Sine. So sine of theta, in this case theta is 53 degrees, equals O divided by H. Right, opposite over hypotenuse. Now, we need to solve for H, and this is a little bit tricky. So don't write this down, just follow along. How do you get H out of a denominator? Multiply by H. So I'm going to times this by H, and those cancel. But now I have H times the sine of 53. So I divide by the sine of 53. Now, you'll notice that those just switched places. Okay? So everybody type in 6 over the sine of 53. And type it in correctly, or you'll get the wrong answer. If you didn't get what I got, you're wrong. You don't need to break your calculator over it. Okay, there are two ways to measure angles. The one you understand is degrees. Degrees make the most sense in the real world. But in the mathematical theoretical world, degrees are harder to work with, so we've invented another type called radians. And radians are the default on your calculator. So push mode, and the third line down, make sure your calculator says degrees and not radians. And in this chapter, everything we do will be degrees, but in the next chapter, we'll do half radians and half degrees. Just push mode and go down to degree and hit enter. Okay, once you fix that, and you just push enter again here, and you should get the right number. And then your calculator will stay in degrees. You don't need to make that change again. Yeah, radians are in terms of pi. Yes. Divide. 6 divide. But you're in radians. So you need to figure out how to change RAD to DEG. Okay. So, let's look at this down here. Yeah, change it to degrees. Okay. We're going to talk about pi day, but we got to get through this. So let's go quickly. Okay. So here I have a 78-degree angle, a 4-inch line. What would this side be called? Opposite. Okay, and what's the name of the side that I know? Wait, what was that, Nathan? So this is called the hypotenuse. So which one uses opposite and hypotenuse? Sine. So we write the sine of 78 is equal to x over 4. Does everybody understand how I set that up? Now in this case, we just times by 4. So the answer is 4 sine of 78. Okay? And really, there are only those two options. If your variable is in the denominator, you do the switch. If your variable is on top, you multiply by the denominator. And those are the only two possibilities. So what did you get there? 3.91. Well, let me show you another one. Okay? So let's find the value of y. What's the name of side y in reference to 78 degrees? It's the adjacent side. Everybody get that? So I have my choice. Do I want to use, I can use opposite and adjacent and use the tangent, or I could use adjacent and hypotenuse and use the cosine. Adjacent and hypotenuse, so let's use tangent. The tangent of, what's theta? 78 is equal to O over A. So 3.91 divided by the adjacent side. You could use a Pythagorean theorem. We're just practicing trig again. So in this case, how do I solve it? Switch. So 3.91 over the tangent of 78. And the answer is 0.83. Right? I'm smart. Okay, I want to point something out. Why is x so big? Why is x so much bigger than y? Okay, explain why. Well, what is it about the triangle that tells us that x is going to be bigger than y? Well, the picture I drew is nowhere, I mean, that's like 5 times bigger. So the picture certainly isn't to scale. It has to do with the angles. So the biggest side in a triangle is opposite the biggest angle. So the biggest angle is the 90-degree angle. So 4 is bigger than all the other sides. Yes? Good question. So Connor wants to know, is the ratio of the sides of the angles equal to the ratio of the size of the sides? And I'll answer that in a second. So before we get to that, let's just talk about which one's biggest. Well, 78 is the next biggest angle, and it is opposite the next biggest side. And then this one is 12, and 12 matches up with 0.83. So why are 3.91 and 4 so close together? Why are those two sides about the same length? Because 78 and 90 are really close together. Why is 0.83 so small? Because 12 is a long ways from 78 and 90. Okay? So if we look at the next one, if Connor's right, so if this is 45 degrees, then that is also 45 degrees. And those two angles are equal, which means these two sides are equal. And if the ratio of the angles is equal to the ratio of the sides, what would the side lengths be? 5 and 5. Is that true? Well, is 5 squared plus 5 squared equal to 10 squared? Not even close. Right? 25 plus 25 is 50. So you're saying that A plus B equals C. That's not the formula. The formula is A squared plus B squared equals C squared. So here's the trick. Can you even make a triangle with a side of 10 and two sides of 5? You can't. If I move this up, oh, well anyway, I didn't draw it to scale, but it won't make a triangle, it will make a straight line. right? So the Pythagorean theorem is true in all right triangles, but A plus B equals C is never true for any triangle. So could I have a 5.1, a 5, and a 10? Would that make a triangle? Just barely, right? So you'd have 10 here, and then a 5.1 and a 5, and they would barely touch and make a triangle. Could I have a 7, a 3, and a 1? Why not? If you had a length of 7 and a length of 3 and a length of 1, 3 plus 1 has to be bigger than 7. So if this was a 4, would it work? Still wouldn't work. What if it was a 4.01? Yes. So the two small sides of a triangle are longer together than the third side. That's called the triangle inequality. We can solve it, but it's not 5, so Connor's question was, no, the angle ratio and the side ratio are not the same. Okay? The sizes will tell you which one is the biggest, but the ratios don't work that way. Okay? So, let's figure out what it is. Let's call this theta. Let's call this x. What ratio am I going to use to figure out x? Opposite and hypotenuse. Which one uses opposite and hypotenuse? So the sine of 45 is equal to x over 10. Is this a switch or a multiply? So my answer is 10 sine of 45. Yeah, you could move theta. Cosine. Right, but in this case, because the two angles are the same, it doesn't matter. Right, they're both... Yeah, if you were over here, then you could... The sine of 78 is equal to the cosine of 12. And that's actually a question on your worksheet. Okay, so 7.07, 7.07. What's the other one going to be? 7.07. How come? The two angles are the same, so the two opposite sides must also be the same. Yeah, you do need to label the units. I haven't been doing that. Well, you'll see later that it, well, I'm not the one who figured it out. Yeah, you'll see it later. Next chapter, you'll see. It just kind of exists. You'll see. Okay, so you'll need to do these two down here and then finish both worksheets.